So myoglobin usually what happens, which is very abundant in the muscle, and myoglobin level we can increase in our muscle daily by doing the exercise. Without exercise, myoglobin content will not increase. So now this myoglobin has got a special feature of taking up of oxygen even at the very low pressure. We know during the time of exercise there will be vasoconstriction whenever muscle contracts and all. Okay, so during that time, whatever in the periphery partial pressure of oxygen is it, that is low. Even in such condition, this myoglobin, because of its high affinity, it can take up more it can take up the oxygen with it. Okay, and it can deliver that oxygen whenever it is required. So and another feature of this myoglobin is it doesn't exhibit the Bohr effect. So now what happens because of it, so it can store oxygen for a longer time, and whenever it is required it can deliver that. So now coming to P50 value for it. So at partial pressure of oxygen 40 millimeter of mercury, so myoglobin can get 95% saturated, and even at partial pressure of 5 millimeter of mercury, this myoglobin saturation with the hemoglobin is around 60%. So we can say it can store the oxygen well within it. And the graph, whatever we get for the myoglobin now, so it is not a sigmoid shaped curve. It is like it is similar to that of an hyperbola. So parabola, hyperbola, all that we studied in a PU level. Okay, so myoglobin oxygen myoglobin dissociation curve has got hyperbola. Okay, the curve is hyperbola curve. Then coming to carbon monoxide. So this carbon monoxide, so the affinity of carbon monoxide to the hemoglobin is 240 times more than that of the oxygen. So it has got a higher affinity to hemoglobin. So but another drawback is, okay, so when one molecule of hemoglobin is there, if it binds with one molecule of carbon monoxide, then other three sides it can bind with oxygen. It won't take up another molecule of carbon monoxide here. So now what happens, this carbon monoxide which is binded to the hemoglobin, okay, now the other three oxygen molecules, so the affinity to this hemoglobin is increased. So this hemoglobin cannot give up these oxygen molecules. Okay, whatever the bond is there, that is very tight, and release is not possible here. So means it, what we are understanding here, carbon monoxide will increase affinity of hemoglobin to the oxygen molecule. Now if affinity of hemoglobin to oxygen molecule is increased, now what happens, the curve will be again shifted to the left side. So another thing is, usually in healthy individual, so this carbon monoxide occupies only 1 to 2% of hemoglobin in our body. Okay, but in case of chronic smokers or the traffic personnel, the one who is exposed to traffic and all, or in the person living in a crowded area, okay, in all of them, so the carbon monoxide occupying percent in our blood is 10%. So if carbon monoxide content in our blood increases, means hemoglobin affinity to oxygen increases, and that hemoglobin, whatever it is, oxygen is bonded to that hemoglobin, that bond cannot be broken and it cannot deliver that oxygen. So here what we can understand is, though oxygen content in the blood is good, but still the peripheral tissue will not receive the oxygen. So peripheral tissue will always get the hypoxia because this oxygen cannot be released by this hemoglobin. And then the final one is P50. So P50 is the level of partial pressure of oxygen at which hemoglobin is 50% saturated. Okay, usually in healthy people at the sea level, hemoglobin becomes 50% saturated whenever partial pressure of oxygen is 27 millimeter of mercury. So previously we studied in case of fetal hemoglobin, it becomes 50% saturated even at partial pressure of oxygen of about 19. Okay, whereas adult hemoglobin at 27. So whenever someone's P50 level means high P50 level is there, means it indicates so their hemoglobin has got less affinity to oxygen and curve is usually shifted to the right side. And if someone's P50 level is low, okay, that indicates high affinity and the oxygen hemoglobin dissociation curve will be shifted to the left side. So in the today we discussed about how oxygen is carried in the blood, and in the next class we will discuss about at the level of tissue how oxygen is getting exchanged, and in the tissue what happens, as well as how carbon dioxide is carried from the tissue back to the lung.